In the sketch below, MNPQ is a kite. MP is 17 centimeters. NQ is 24 centimeters. And angle Q1 is 45 degrees. A, prove that OP is equal to OQ. And B, calculate the length of MQ. Let's start with part A. Prove that OP is equal to OQ. OP runs from the intersection of the diagonals at point O to a vertex on the kite at point P. Let's make OP red. OQ runs from O, the point of intersection of the diagonals, to the vertex on the kite at point Q. So let's make OQ red as well. The question tells us that MP is 17 centimeters long. From the diagram, we can see that MN over here is the same length as MQ. So MP is the main diagonal. We don't know how long MO is, so we can't use this to find the length of OP. But the question also tells us that NQ is 24 centimeters long. So let's make a note that NQ is equal to 24 centimeters. And we know this because this has been given to us in the question. Now, in a kite, the main diagonal bisects the other. So in this case, the main diagonal MP cuts NQ in half. This means that NO is equal to OQ. And both of these are equal to half the length of NQ. So both of these must be equal to 12 centimeters. And as our reason, we say because the main diagonal of a kite bisects the other. Let's put 12 centimeters into our diagram for NO and for OQ. We now know that OQ is 12 centimeters long. So to prove that OP is equal to OQ, we need to prove that OP is 12 centimeters long as well. But we don't know anything about the length of OP, MO, or any other side of the kite. So what do we know? The red line on OP and the red line on OQ show us that both of these lines sit on triangle POQ. So let's make PQ red as well. We know from our work with triangles that if a triangle has two equal sides, then it has two equal angles as well. But this works the other way around. If a triangle has two equal angles, then it's an isosceles triangle and has two equal sides as well. So in order to prove that OP is equal to OQ, we need to prove that angle Q1 is equal to angle P2. Let's see what we know about these angles. The question tells us that angle Q1 is 45 degrees. So now we can say in triangle POQ, we know that angle Q1 is equal to 45 degrees because this has been given to us in the question. Let's put 45 degrees into our diagram for angle Q1. We also know that the diagonals of a kite are perpendicular. This means they create 90-degree angles between each other. In triangle POQ, we can see that angle O1 sits between two diagonals. So let's draw in a 90-degree angle. And now we can make the note that angle O1 is equal to 90 degrees because the diagonals of a kite are perpendicular. Now we have two known angles, so we can use the interior angles of a triangle to find the size of angle P2. So we can say angle Q1 plus angle O1 plus angle P2 is equal to 180 degrees because these are the interior angles of a triangle. Now we can fill in our values. We know that Q1 is 45 degrees, so we can say 45 degrees, plus O1, which we know is 90, so we can say 90 degrees, plus P2, the angle we're looking for, is equal to 180 degrees. And now we can solve. 45 degrees plus 90 degrees gives us 135 degrees, plus angle P2 is equal to 180 degrees. Now to get P2 by itself, we need to subtract 135 from both sides. So angle P2 is equal to 180 minus 135, which leaves us with 45 degrees. Angle P2 is also 45 degrees. So let's put 45 degrees into our diagram. OQ lies directly opposite the 45-degree angle at P2, and OP lies directly opposite the 45-degree angle at Q1. So we can see that OP is the same length as OQ because these sides lie opposite the equal angles. We know that OQ is 12 centimeters long, which means that OP is also 12 centimeters long. So let's put 12 centimeters into our diagram for OP. Calculate the length of MQ. MQ is a side of kite MNPQ. So let's make it red. Now we know that MQ is the same length as MN, but without a given length or the size of Q2, we don't have anything else to work with. Now, even though we are working with quadrilaterals, we can still use triangles to help us. MQ lies in triangle MOQ. So let's make this triangle red. Now let's look at the information we have in triangle MOQ. We know that just like angle O1, angle O2 is 90 degrees. So let's make a note that angle O2 is equal to 90 degrees because the diagonals of a kite are perpendicular. So let's draw in a right angle. We also know that OQ is 12 centimeters long. So we can make a note that OQ is 12 centimeters. We proved this in part A. We don't need to prove this again. So as our reason, we say proven above. Now we have a right angle triangle and one known side. So we could possibly use Pythagoras' theorem to find the length of MQ. But to use the theorem, we need two known sides. So we need to find the length of MO. We know that MO is equal to the length of the diagonal MP minus OP. The question tells us that MP is 17 centimeters long. So let's make a note that MP is equal to 17 centimeters. And we know this because this has been given to us. In part A, we also found that OP is 12 centimeters. We've already proven this, so again, we can use proven above as our reason. Now we have a length for MP and for OP, so we can say MO is equal to MP 17 minus OP 12, which means that MO must be equal to 5 centimeters. Let's put 5 centimeters into the diagram for MO, and now we can make some space. Now we have a right angle triangle with two known sides. So we can use Pythagoras' theorem. MQ lies directly across from the 90-degree angle, which means that it's the hypotenuse. So we can say the length of MQ is equal to the length of one side, let's say MO, squared, plus the length of the third side, OQ, squared, all under a square root. Now we can fill in our values. We know that MO is 5 centimeters, so we say 5 squared, plus the length of OQ, we know is 12 centimeters, so we say 12 squared, all under a square root. Now we can take our calculator and we say the square root of 5 squared plus 12 squared is equal to 13. This is the length of MQ, and we have now completed this question.